Which figure shows how a plot of the pressure volume product Y varies with absolute temperature X? So let's imagine, let's take a look at PV equals nRT to illustrate what's going on here. We're told that we're told that N is 1, so we can pretty much just ignore that. It's just 1. R is a constant, so ignore that for now. And so what we're left with is that PV is proportional to T. And we can even just say KT, where K is some constant, which is the product of N times R. It doesn't really matter. You can just leave that out if you want to. So what's this telling us? It's telling us as temperature increases, PV, that product will have to increase. As temperature decreases, PV, the product, will have to decrease. You can think of it mathematically. If P times V is some value, and that equals nRT, where N and R are just always the same, as T changes, you're going to have to change PV in that same way to make the equation still equal. So as T goes up, PV goes up. As T goes down, PV goes down. So we're looking for a linear direct relationship, and we get that in choice E. How about 24, which shows a plot of temperature versus time for the conversion of a liquid to a gas. So we're looking for phase changes, and typically what you see is what we see in choice D. Over time, this X is the time, which is kind of a proxy for the heat that's being applied, because you're heating this thing over time, and so as time goes on, you're adding more and more heat. And here we've got temperature. And so as you're heating this liquid, its temperature goes up, 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 and then it flattens. And what's going on in this flat period is that phase change from liquid to gas. In any phase change, as you add more and more heat, that heat goes into making the phase change happen. And so it doesn't raise the temperature, which is why over this period, it goes flat, because that's where the phase change happens. So here we're liquid, here we're going to gas, and then once we completely convert to gas, then the temperature starts going up again as per normal. So we get D for 24. 25, which shows a plot of the fraction of molecules in a gas sample versus kinetic energy. So this is just a good one to recognize. It looks like choice B, where the kinetic energy is X, and the fraction of molecules, or the number of molecules, however you want to call it, is the y-axis. And so what you get is a certain distribution of molecules at certain temperatures, or sorry, at certain kinetic energies. I wouldn't worry too much about this. Just know what this looks like. Know that to recognize that this is what the answer would be. We don't have to go into much more detail about what it means. Also note that as kinetic energy increases, or as temperature increases, the average kinetic energy goes up. So what happens over time is you start kind of flattening out the curve like this as you change your kinetic energy. This peak will move as you change the temperature to various places. So if you know those things, that's good, but you don't need to know much more about it. C is another diagram that shows phase states, solid, liquid, gas usually, for a given pressure and temperature, or actually it should be the other way around, temperature and pressure. You don't really see these on more modern tests very often, but if you know the basics of what that looks like and how it's used, that would be great, but I wouldn't worry too much about this. A would show something in which there's no relationship between X and Y, right? As X goes up, Y doesn't change. So if there was anything that had no relationship, we would pick A. But for this case, in these three questions, our answers are E, D, and B.